All of IAC silencers and louvers were developed in response to the specific requirements from acoustic consulting engineers, building owners, and contractors. That being a complete range of sound attenuators for controlling the noise in air handling systems. Silencers to reduce sound transmission through air ducts, servicing multiple spaces to allow conversational privacy between rooms. Acoustic louvers for use around mechanical plant installations where an acoustic barrier may be required and that airflow is still needed. And of course, aesthetic type louvers that can come in many different shapes and sizes and still carry acoustic performance requirements. All having been tested and performed, our entire line of HVAC products provide the most economical choices for solving the wide variety of noise control problems encountered in HVAC engineering. Since being founded in 1949, IAC Acoustics has been a leader in the sound control and noise reduction industries now for 67 years. We've come a long way from just being a one-man operation in New York, and today we are now part of an exciting and bigger plan, as IAC Acoustics has now partnered up with and is now a division of SoundSeal, who is the leading manufacturer in industrial acoustical noise control products. Combining our engineering and our resources and our products now gives you even more to choose from and to work with. As we move through the presentation, we're going to cover, for the most part, the basics within the following: IAC Acoustics, SoundSeal general information and contacts, dynamics of duct silencer design, some basic silencer terms, definitions, and performance criteria, and different types of IAC acoustic silencers and louvers. As many of you know, again, IAC Acoustics is now a division of SoundSeal. It's exciting times, and for a little bit about SoundSeal, they were founded in 1978. They are headquartered and located in Agawam, Massachusetts. SoundSeal is a leading manufacturer of commercial and acoustical architectural noise control products, and they offer a wide product selection to the soundproofing industry. They manufacture acoustical materials, components, and systems such as industrial curtains and enclosures, architectural panels and baffles, wood walls and ceilings, acoustics, floor underlayments. In October of 2014, SoundSeal acquired INC, also known as Industrial Noise Control. They are located and headquartered in Aurora, Illinois. They have rigid material, architectural panels and ceilings, sound curtain blanket enclosures, quilted fiberglass absorbers, and much, much more industrial-wise. And now we have good old IAC Acoustics. In December of 2015, SoundSeal acquired IAC Acoustics. We, too, are now also located and headquartered in Aurora, Illinois. Yet the HVAC products are manufactured still in New York and in Southern California. In North Aurora, Illinois, are doors and windows. This is where they are fabricated. Combining all three, SoundSeal, INC, and IAC, we have 30+ years of experience and know-how. A large, vast array of products, 40+ years of engineering, experience, and products that are sold through distribution. Now, let's take a look at the dynamics of duct silencer design. Number one, a die-formed single-piece splitter construction throughout. Number two, shell noise radiation minimized by double scanner splitter construction. Number three, acoustics baffles that are designed for maximum attenuation at low frequencies, the toughest job of all to attenuate. Number four, straight through air passages. designed for maximum air handling at minimum pressure drop. Number 5, solid round noses that increase noise reduction. Number 6, bell mouth entrance and exit to minimize turbulence, pressure drop, and self-noise. And I might say either end can be the entrance, either end can be the exit. No protruding fastener is number 7. That can cause turbulence or self-noise. Number 8, solid air impingement air passages to minimize dirt entrapment. Lastly, number 9, the acoustic fill, which is protected against erosion by perforated metal contaminants. Here we will now touch on some of the basics of these within the webinar. Should you have the need to go deeper into any of these terms and definitions, please feel free to call me or email me after the webinar or any later time, whichever is convenient for you, and we can discuss these in depth. First, we have face area. This area is calculated by taking the width times the height of the silencer. For example, say that we have a 24-inch wide and you have a 24-inch high silencer. When you calculate that together, you get 576 square inches. Converting that over to square feet, you now have 4 square feet of face area. We then also have face velocity. This is calculated by taking the airflow rate, CFM, and divide by the face area in square feet. In the example of this, let's take airflow and say 5,000 CFM, divide by the face area, and let's use the same 4 square feet from what we just calculated. You then get 1,250 feet per minute, FPM. Next, we have percent of open area. This is calculated 2 AP divided by width, and AP is air passage. Please note here that half gaps and half baffle thicknesses are H and D respectively. And performance is only based on these parameters. Now, let's take a look. Here we have a single silencer on the left of the screen. Now take a look at the 3 silencers we have on the right side of the screen. All having different configurations. Yet, all have the same acoustical performance, but that of the one on the left. Thus, assuming the dimensions for H and D and L are the same. The number of baffles and air gaps only affects the flow area, as does the height and or the span of the baffle. Having more baffle arrangements within the silencer, you will then have more flow area. You will also have lower air gap velocity and lower pressure loss. Now let's take a look at flow directions. At the top, we have positive flow, also known as forward airflow and commonly known as exhaust and supply flow. This is the condition that exists when airborne sound and airflow are moving in the same direction, say as in an air conditioning supply system or fan discharge. Under forward flow conditions, high frequency sound is refracted into the duct silencer walls. Now at the bottom, we have negative flow, also known as reverse airflow and commonly known as inlet and return airflow. This is a condition that exists when sound waves and airflow are traveling in the opposite direction, as in a typical air return system. Under reverse flow conditions, sound is refracted away from the walls and into the center and towards the center of the duct silencer. Moving on to, we have insertion loss. On the left, you see the sound source. On the right, you see the receiver. Insertion loss is the decrease in sound pressure level or sound intensity level measured at a receiver when the silencer or sound attenuating device is inserted. And here you can see it's inserted down here below. It is inserted into the path between the sound source and the receiver. These units of measurements are in dB. And at the bottom, you see a nice handy-dandy calculation should you need to calculate this type of loss. Now let's take a look at dynamic insertion loss, also known as DIL. You see that a lot of times on silencer schedules. First, insertion loss depends on the flow, if it's forward or reverse. Next, here as it is shown, it is forward, showing air flowing in the same direction as the propagation of sound. So for this type of loss, this would then be the difference between the sound source power or intensity levels measured at the same point of the ductwork before and after the insertion of the silencer. Again, here at the bottom, you see this specific type of calculation should you need to calculate this type of loss. Right here is a very good example right out of our IAC HVAC quiet duct silencer catalog. These types of tables are great for engineers and acoustical consultants, as you now have the needed provided information for creating your basis of design. This specific dynamic insertion loss table is for the IAC LFS type silencer. It's a very common silencer that has been pre-engineered and tested for acoustical performance and aerodynamic efficiency, all in accordance with ASTM E477-99 and carries the NVLAP accreditation and certification. Transitioning to pressure drop, PD, commonly also known, and you'll see that on the schedules. This is a difference in static pressure from the inlet to the outlet of the system. The upstream location is to be a minimum of 5 diameters equivalent, and the downstream location is to be a minimum of 10 diameters from the silencer. When adding any component to an HVAC system, the pressure drop should always be considered, because a poor silencer selection resulting in a high pressure drop can make the entire system operate inefficiently and ineffectively. What you see pictured here is a measurement process. As the airflow enters, there's a pitot tube. This is used to measure the flow rate. Then, a manometer is also used. This is an instrument that uses a column of liquid to measure pressure. Plugging both of these measurements results together will then give you your end pressure drop reading. With commercial type silencers, pressure drop typically ranges from 0.01 to 1, but it is best desirable to keep the pressure drop below 0.35. Here again, right out of our IAC HVAC catalog, is the pressure drop table for the IAC LFS type silencer. For each type of silencer, we provide this type of information, and again, this is great information, readily available at all times. The testing and data performance you see here has been done per an aerodynamic aeroacoustic laboratory conducted in strict accordance with ASTM E477-99. Now, let's take a look at self-noise. This is where noise is generated in the silencer at a given velocity. It is also the noise power level in decibels generated by the silencer when inserted into the airflow. When air or gas flows through a baffle or silencer, the interaction of the fluid flow causes flow disturbances, resulting in flow noise. As velocity increases, so too will the flow noise. Self-noise is important, since these values represent the amount of sound produced by the actual silencer. A lower value indicates better performance. Silencers are used to reduce mechanical equipment noise transmitted through the ducting system, achieving desired noise criteria in an occupied space. Our entire line of silencers have been designed, engineered, and laboratory tested, and with our bell mount entrance and exit, which is again is the IAC unique and overall design, this test minimizes turbulence and self-noise. Some sources of self-noise. Here on the top left, you see some self-noise can be caused with the interaction with an appropriated material of the silencer. To the top right, some self-noise can be generated right at the entrance of the silencer. And here at the bottom, this illustration here, you see some self-noise can be generated at the discharge of the silencer. With the effects of separation of the airflow, this could cause some turbulence within the airflow. But with our bell mount entrance and exit, this is minimized because the airflow can mate up together and have a continual flow. Here again, self-noise table right out of the IAC HVAC catalog for the IAC LFS type silencer, and this is provided for every silencer within the HVAC catalog here as well. Moving down our list, next we have film liner for silencers. This is a thin polymer film liner that encapsulates the acoustic media for added protection and can be applied to our entire line of silencers, which is an added extra feature that does provide an added extra cost associated. Some of the typical line silencer applications include healthcare facilities, laboratories, and air intakes at critical building openings. These added polymer film liners ensure that fibrous media particles from the silencer do not enter the airstream. Even better, we here at IAC have the ability to provide heat-sealed polyethylene bags, which provide an even greater reassurance that fibrous media particles from the silencer do not enter into the airstream. This can also be applied also to installations where individual modulars are banked, thus having the ability to wash down the silencers as well. We did a job at the University of Mississippi where banked silencers were installed for the veterinary labs at the university, and they needed just this type of application. And once they were installed, I was able to be there to witness the very first washdown and to see firsthand how these heat-sealed bags held up under these conditions. It's normal washdown. It's a bottle of water or some detergent, and you could spray the outside perf and just simply wipe it down with a cloth. I will say this, so please note, do not use a power washer. Lastly, the film liner you may see, it is typically named Mylar, and a lot of times you're going to see this in the job specs. This is the actual branded name. We here at IAC call it by its material composition, also known as polyethylene. So please do not be confused when you see this on our literature, as they are one in the same. Okay, let's now hit on some of the basics of our silencers and louvers. Here at the top, we have our Quiet Duct Ultra Low series. These were first introduced back in 2005. They were designed to optimize dynamic insertion loss performance with frequencies between 25 and 80 hertz. This line of silencers offers to the industry, first to be published by IAC Acoustics, a guaranteed performance data in 31.5 hertz full octave band center frequency. Next, we have our Quiet Duct Ultra Green, commonly known as our UG type silencers. This line of silencers were developed in response to the trend for environmentally friendly building projects and products. This 100% environmentally friendly attenuation solution uses recycled acoustic field material and delivers performance that meets or exceeds that of a standard quiet duct silencer. Moving on down, our Quiet Duct Ultra ZAPD, Zero Added Pressure Drop. This specific line of silencers has been designed for applications in which acoustics attenuation is required and no allowance can be made for pressure drop loss. A zero added pressure drop silencer is ideal for high velocity systems or systems that have little or no room for additional pressure drop. And right here is a pictorial of what one looks like. Moving on down, we have our quiet duct commercial series. This series of silencers here is the backbone of the IAC HVAC silencers. Hundreds of sizes have been designed and pre-engineered and tested for acoustic performance and aerodynamic efficiency. These are the most used and spec'd out silencers within the industry today. They provide an awesome design flexibility suitable for many different types of HVAC applications and can be easily fitted and or retrofitted into any existing system. Moving on down, we have our quiet duct clean flow series, commonly also known as our hospital grade, as you'll see the H in front of each different type of silencer. This specific series complements the commercial series as it takes the same high efficiency attenuation and applies it to the clean flow series, as these silencers are non-erosive, non-pregnable, cleanable units with a protected acoustical fill completely separated from the interior perforated baffles by way of an acoustical standoff. These units can also come with the heat sealed bags as an extra added cost. Here we have our quiet duct conic flow series. These are the IAC's round silencers. Circular silencers are an excellent solution when you have round ductwork being utilized and installed. These types of silencers eliminate any need for square to round transitions that can cause you to possibly have a system effect where you may have an undesirable drop in pressure drop. Also, these circular silencers work equally well in both high and low velocity systems. Lastly, here on this page, you see our D-duct diffusers, also known as axial type silencers. These silencers are designed to be close coupled to an axial fan. They have been designed and engineered to provide sound attenuation directly at the source and to help improve aerodynamic performance at the inlet and discharge ends. The center hub, that you see right here, and here is, again, another pictorial of what a D-duct diffuser looks like. The center hub has been designed and engineered and is properly sized to help reduce the pressure loss in conjunction with the fan. Back up at the top, we now have our Ultra Pals, our packless silencers. The packless type silencers have been developed, designed, and engineered to provide a solution to HVAC noise control applications where fibrous acoustic material is not permitted into the airstream. They are ideal suited for ultra-clean environments such as operating rooms, clean rooms, lab rooms and facilities, and food and or drug-related processes. Again, the absence of the fill material prevents collection of airborne contaminants. Here to the right, you also see what is called a tubular packless. This is a tubular packless elbow. This would be the TXLB. We also have the TXSX and the TXL, which would be a straight type rectangular silencer with a tubular packless inside as well. And these can be done in either 8-inch, 10-inch, or 12-inch round for the tubular portion. Lastly, we have our quiet duct elbow silencers. Here below is a pictorial pic of our elbow silencers. They are commonly known as our ELBMs, and we also have different baffle arrangements that can be achieved in our elbow silencers. The elbow silencer features a capability to both nest and stack the elbow silencer individual modulars, so the size can be scalable while the aerodynamics and acoustic performances are still maintained. Please note, elbow silencers will provide a slight increase in pressure drop on the system. For more silencer information, you can visit our website here at www.iacacoustics.com, and you can go on to the commercial construction, and right there you see the HVAC catalog, which is downloadable in PDF format. Let's move back up here to this page, and we see our noise shield louvers. These are the louvers with the airfoil, the curved type splitter blades. Our commonly used ones are the Model R and the Model LP. We also know, and again, these are 12 inches in depth. We also now have the capability of providing these in 24 inches in depth, and they will have the chevron look. These louvers allow for ventilation while reducing noise transmission from building machine rooms. These have been designed and engineered as a high-performance solution to unwanted noise. You see to the right, we also have the capability of doing louvered doors. Lastly, we have here is our slope shield louvers. Everyone's familiar with our popular SL4, 4 inches thick, our SL6, 6 inches thick. We also now have the SL12 and the SL24. The slope shield louvers, all of these 4 models have these straight splitter blades. And these models are compact for use in walls, doors, or equipment enclosures where airflow is still required. And yet again, you can go under www.iacacoustics.com under commercial construction and look for the louver portion. And again, there you can download the new louver brochure. It is in PDF format. So we'd like to end the webinar here with today's question: which of the following silencers would provide the highest level of attenuation? I'd like to hear from you all. So if you would, email me your answer and why. And it can open up a door to some great discussions about HVAC type silencers. To everyone, I want to thank you for your time today, and thank you for attending our webinar. Hopefully you have enjoyed this and are able to take away some knowledge and or some well-needed information. It has been a pleasure to bring to you this HVAC IAC Acoustics webinar. If you need additional information, you can reach out to either myself, Darren Riley, or any of the application team members here at IAC Acoustics that you see listed. Again, we are now a division of SoundSeal. Enjoy and make it a great day. Thank you very much.